Okay, in the last video we have discussed how to reduce a second order system into a first order system, and also we have justified under what condition that can be reduced. But still there is an unresolved issue, okay, which is the following. So if you see a second order system which is in the following manner, say x double dot or epsilon x double dot is equal to x dot, okay, minus f of x. So that was the equation, that was the form of the equation, and we have made this to this form: x dot is equal to f of x. So taking this second order term into first order term under the condition when epsilon tends to 0, okay. When epsilon tends to 0, then I can write this form to this form. Fine, but there is an issue. Issue is, let's say this epsilon is not getting vanished and it's some considerable value, then I require two initial conditions to solve, okay. So those two initial conditions are, what is x naught, okay, which means what is the x at t is equal to 0, and also what is the initial velocity, right, what is the initial rate of change of x. But here we use only one initial condition, which is just x naught, okay. So basically for the system I'll be able to choose different initial velocity, but here I will not be able to choose a different velocity, because for a given x naught there will be only one x dot 0, right, x dot naught. So there is a contradiction, and that's what we call as paradox. And so in this video let's see how to resolve that paradox, okay. So for that what we are going to do is we are going to plot x and x dot, okay. Let's say this is my f of x. So let's say this is my x naught, okay. If this is my x naught, then this equation says that's going to be my x naught dot, okay. That is the only x naught dot possible, okay. But according to this equation I could have this one or this one or anything, right, along this line, any value for x dot I could choose, okay. So what will happen, my epsilon tends to 0, okay. What will happen is, let's say my epsilon tends to 0, but at the same time I didn't choose my x dot naught over here, but somewhere here, let's say this point, or say this point, okay. This is my initial condition. That time what will happen is the system will accelerate rapidly, okay, towards this curve, okay, towards this curve, and then try to reach near to this curve, and then it will start behaving in this manner, okay. So let's say it's going like this something, okay, and then it starts flowing along with this curve. Okay, so that's how the behavior will be if the epsilon is very small. Okay, if not, it's going to have a different behavior, and that behavior we will learn in once we get to know about 2D systems. Okay, so yeah, so that's how we could resolve the paradox when epsilon tends to 0. Okay, so with some other example we'll see in the next video. Thank you.